Welcome. I hope you're having a great re:Invent. My name is Brian Zambrano. I am a senior deep learning architect at AWS. And if you're wondering why a deep learning architect is talking to you, it's because I come from a background of development. So before this, I was a specialist, a serverless specialist solutions architect, and a regular account solutions architect before that. So I come from a long history of building applications. So today we're going to be talking about building real-time applications at scale. And with me here today is my colleague over here who will be talking to you in a bit, named Kim Wentz. So we're really happy to be talking to you all, and let's get into it. So if I threw this out there, building applications, what's the first thing that comes to your mind? Building applications is what? Easy, hard, challenging, complicated? I think even in today's world of GenAI, things are still kind of complicated. I mean, building a real-time an application in general, you've got to deal with monitoring, your application logic, databases, caching. There's a lot going on when we're building any kind of an application today. So now what happens if we add in something else? So building a real-time application. What does that mean? A real-time application is something where something happens and we're going to produce some event or push some data out to another user in real time or near real time. So what is that? That's even harder, right? Again, even with the tools that we have today, this adds additional complexity that you have to deal with. So what about now if we're adding another component to this? Building a real-time application for millions of users is what? It's really hard. There's a lot going on that you have to consider here. So you're going to be the scared cat trying to figure out, what do we need to do? What do I need to do in order for my business to succeed when we're dealing with a real-time application and millions or thousands and thousands of users? So we're going to go through a lot of that today and how you can do that and take that back to your organizations and be successful. So to get started, we're going to do this in real time. So let's play a little trivia app. So this is the time where you all get to pull out your phones or your laptops, scan this QR code, and you are going to end up at our trivia application that Kim and I built. So I'm going to swap over to here, and I'm going to be running an admin. So we're going to play AWS trivia now, all right? So I'm going to come over, and do you guys need the QR code? There you go. So while you're doing that, I'm going to load it up on my side. Does everyone have it? All right. I'll give you guys a couple more seconds. Are we good? Yep, okay. Okay, so this is going to be AWS Trivia. So you should have it on your phone. If you click the link on the landing page that you landed on, you'll be in a state where it says waiting for the game to start. So does everyone see that? Waiting for thumbs up if I see that? Okay, great. So let's play. These are kind of hard questions, and for that you can blame Kim or actually Kiro. She did a lot of these with Kiro using GenAI to come up with the questions. Okay, so let's start the game. Which Amazon Bedrock model provider is known for highly efficient long context processing? So I see a bunch of answers coming in. The answer is A. All right, we'll go to the next one. What does Amazon SageMaker pipelines provide? All right, CI/CD for ML workloads. So you'll notice here, you'll see that the leaderboard is changing. On the bottom right, we're getting the answers coming in, streaming as you're all clicking buttons. Let's go to the next one. Which Amazon Bedrock feature supports multi-turn conversations? 2 more seconds. Knowledge bases, nicely done. What command launches Kiro in interactive chat mode? Kiro CLI chant's the right answer. I told you these are kind of tricky. Which SageMaker feature provides granular hardware profiling insights? And we see all the answers coming in over there on the bottom right, which is really fun. Profiler. I'm going to make this one notch bigger. Next question. Which SageMaker feature helps reduce foundational model training times by up to 40%? Hyperpod. All right, our first place is at 274 points. So there's 10 questions, so we've just got about, 3 or 4 more. What capability does Kiro have for AWS resource management? Full AWS CLI integration. Okay, last couple. Which Amazon Bedrock capability allows models to take actions and call APIs? Agents. Yeah, hopefully people got that one because agents are the name of the game now. 2 more. What type of evaluation does Amazon Bedrock model evaluation support? Both automatic and human evaluations. All right, last question. What can Kiro do with local file system operations? Read and write files. All right, well, congratulations for playing AWS Trivia. You should have something on your screen that gives you your username is actually at the very bottom of that, and it's going to give you your total score. So if you are user 548, this one over here, congratulations, you were in first place. So if you guys want to take a screenshot of that and claim your first or second or third place prize, which is just a pat on the back, feel free to do so. But hopefully that was fun and a good way to kick this whole thing off. Okay, so that was a real-time application. So what are some other examples of a real-time application? So we're here in Las Vegas. You might have noticed you're using a ride-sharing app. So the location of the rides that are going on, that's an example of a real-time data that is being pushed all over the place. Some other examples would be sports scores. So I happen to be a Denver Nuggets fan. So whenever the Denver Nuggets are playing, I see a notification on my watch from Alexa giving me the game is starting, the score, halftime score, things like that. Price changes, betting odds, updates, things like that. Gaming is another popular example of a real-time application. So these applications are all over the place, all around us today. There's also different versions of this, which are collaborative real-time applications. So the one I mentioned earlier with ride sharing. So we all, if we're looking at a ride sharing application, we all together see the locations of the rides at the same time in real time. Some other ones would be, again, I mentioned, a multi-turn game application. So we're all playing the same game. We're all seeing the same data move in tandem together. So if your organization came to you and asked you to build this, where would you start? How would you start thinking about this process of building this type of an application where data is being shared in real time across many, many users? Well, most of us, myself included, have used polling. Who here has used polling in the past when they're building some sort of an application? You need to get updates to your users. Yeah, most of us. And there's no harm in doing this. There's no problem with using polling. It's fine to get started with this. And the way it works is that the front end or the application is going to keep going back to the server over and over again saying, is there an update? No, there's not an update. How about now? Is there an update now? And so this pattern goes on over and over again. And eventually, you're going to get that there is some new data available. That gets pulled into the front end application or the application, and then you move on. You can present that information to your user. So while this is not inherently the wrong way of doing things, it does break down at scale. You do waste compute cycles, you waste network bandwidth. So it's fine to get started and is an easy thing to use at the beginning, but eventually you're going to want to graduate to something that is a little bit more sophisticated and more efficient as your application and your user base grows. And so for that, a better solution is bidirectional communication. And for that, we're going to leverage WebSockets. And if you're not familiar with that, the way it works is that the client is going to make a request to the server, and the server is going to respond with an acknowledgement saying, like, I've acknowledged your request for a connection. And at that point, the client and the server have established this connection, and both of them can push data back and forth between that connection, and it's persistent. So hence the term bidirectional. The client can push data to the server, and the server can push data to the client. So again, the challenge now is that we're adding scale. So this can become more and more complex as your application grows. So the first thing is that everyone who's connected, so all of you in the audience, when you were connecting to our trivia application, we have to know who you are. Each one of you had a unique connection to our backend system. And so if you're building this on your own, you're going to need to keep track of that. So who is the user? Who's this user in the front row who's connected to the back end? How do I know that that user has sent me this specific answer to a question? So you have to keep track of all that. The next thing is something known as fan out. So that is, as you noticed when we were playing the trivia app, the admin page was showing all of the updates coming from all of you users. So as you were sending that to me, that was coming into the admin interface. As I'm sending things to you, I'm fanning out the questions so that all of you receive the next question. So how do you do that? There's probably maybe 150 of us here in the audience today. So how do you do that with hundreds, thousands, tens of thousands of users where one message is now broadcast out to many, many users? So doing this on your own, you're going to have to keep track of that. How do you do fan out? And then along with that is, as the application grows, as you're supporting more and more users, how do you scale that? So maybe you start off with 100 users, but then the next week you have 1,000, and then after that you have 10,000. So how do you scale the back-end infrastructure, the servers, to handle all of this? So the bottom line is that over time, as your app evolves, as the scale increases, a lot of the work that you would need to do managing this yourself would be what we consider undifferentiated heavy lifting. So this is not your core business, but it's things that you have to keep track of when you're building your application. Again, keeping track of scale. Okay, so we're going to go through a lot of these challenges and give you some solutions. So if the agenda is going through this bidirectional communication and how you can handle that and solve for that with AWS AppSync events. So that's going to be the core of the technology stack that we're using that powers our trivia app. So we're going to go through how that works. The other thing is how to manage your backend, how to design your backend for scale. So think considerations and solutions for challenges there. We'll touch on application hosting. So if you're doing front-end application hosting, we'll talk about a solution there. And then finally wrap it up with some monitoring and observability and a final wrap-up. So with that, I'm going to hand it over to Kim, who's going to get into AppSync events.
Awesome. Thanks so much, Brian. So you've all have heard about the challenges with building these real-time applications. Brian talked a little bit about how building WebSockets can be pretty complex, but bidirectional communication seems to be the way that we can make these real-time applications work better. So how do we solve that with one of our AWS services? So who here has heard of AWS AppSync events? Raise your hand. Okay. We've got some hands up, so this might be a little bit of a review for you folks, but for the folks who haven't heard about AppSync events, let's talk a little bit about it. So AWS AppSync events is a fully managed pub/sub service. Its core competency is making it easy to build an API that can provide that real-time communication between publishers and subscribers. We do this by reducing the operational overhead of managing and operating WebSockets at scale. We provide things that help you do authorization for your APIs, a way for you to inject business logic into your API when you're publishing and subscribing. And we do this at a very low total cost of ownership for you when you're building these APIs. So let's talk a little bit about how it actually works. So your publishers, those are on the left-hand side of the screen. These might be your application clients, right? Your mobile app that you were just using to play our trivia game is a good example of a client that might be publishing information. But this could also be back-end systems like a Lambda function or an Amazon EventBridge event that's coming through, publishing information or triggering a publish. On the right-hand side, these are your subscribers. These are the entities that are interested in the information that you're publishing. These can also be application clients, again, like the mobile device that you were using to receive the questions in real time, but these could also be backend systems as well. Maybe a container that's listening for information over that WebSocket connection to do some processing based on the events that it receives. All of this behind the scenes is managed through WebSocket connections. So AWS AppSync Events takes away the heavy lifting of managing that WebSocket infrastructure and provides built-in connection management out of the box. What that really means is that AppSync Events is tracking all of the connections that are coming through to the API and keeping track of which connection is interested in which information. And additionally, it also handles all of the fan-out capabilities, right? So all of the questions that you were getting is a really good example of a fan-out process. We were publishing once, and you all were receiving that. AppSync Events handles figuring out who needs to get that information when we send it over a publish operation. At the heart of this is the Event API. This is what you configure to leverage AWS AppSync Events. And one other important thing to kind of connect your publishers and subscribers together is this idea of a namespace. We're going to talk a little bit more about that next, but think of this as kind of that segmentation of information and events. So what is a channel namespace? Let's kind of double click on this a little bit. So while you were playing the game, we were using different channel namespaces to support different parts of the game. So the first part of your channel namespace is the namespace. This is the highest level of cardinality that segments different events that you might send through your Event API. So before, Brian was talking about sports. He mentioned, I think, the Denver Nuggets and I think that's basketball if I'm remembering correctly. I'm definitely a big football fan, and so we might have an API that supports a bunch of different sports, and the highest level of cardinality to kind of split those might be the league. So it could be the NFL or the MLB or the NHL, right? The highest level of cardinality that can split your events. For our use case, we have a namespace called game. That allows us to handle different join operations as you're connecting and interfacing with the game itself. The second portion of this channel namespace, these are the channel segments. And what's really interesting about these is that these are dynamically created. So you don't actually have to predefine these channel segments when you're thinking about what I should include in my channel namespaces. The only thing that you define up front is that top level namespace to kind of organize your events. The channel segments then are created as somebody publishes to it or somebody establishes a subscription to it. And so it gives you a lot of flexibility in what information you can send and at what level of segmentation. So let's dive a little bit deeper into kind of how this works and tie it into our trivia game that y'all just played. So our publishers are the application clients for some of our use cases, right? So you had your mobile phones and you were actually publishing your answers to an answer namespace. That answer namespace then had a segment that was the game ID, right? That RIV2025, that helped us segment the different games that we might play. And you published over a WebSocket connection. So when you opened up the trivia application, you created a WebSocket connection behind the scenes, and you're publishing information over that WebSocket connection. But we also have cases in our trivia app where we might be publishing from backend systems. So AWS Lambda functions, some of you might know, are ephemeral environments. So it doesn't really make a whole lot of sense to open up a WebSocket connection from within a Lambda function and then send information through it, because that's only going to be open for about 15 minutes at most, probably less. And so for that use case, when we're publishing the questions, we're actually doing so via HTTP post operations. And this is a really unique differentiator, I think, in AppSync Events, is that you can do both. So for the cases where you need that WebSocket connection open, like for an application client, like a mobile device, you can publish over that same WebSocket connection. But for cases where you have backend systems, you might want to just publish over HTTP because it's an ephemeral environment. But then for our subscriptions, so again, our clients that you guys were using, you'll always subscribe and get updates over a WebSocket connection. That's how we get those updates in real time. So now let's dive in a little bit more to how we built our game. And I know with this audience, we're clearly not scaling to millions, but what we're gonna try to do is talk you through how we built this game. And we thought about, well, what if we had thousands of people playing our game? Like, how would we build this? Would it scale? So I want you to keep that in mind as we're going through. There's 3 main portions to our game. The admin side is pretty boring. We actually just used REST APIs to do it. There wasn't really a whole lot of real-time stuff that we needed to do from an admin perspective. And so we're gonna focus more on joining the game, and then I'll pass it back to Brian to talk about playing the game a little bit later. So when we thought about, well, what does it mean to scale the join process? There were kind of 4 main areas that we thought about for when we were designing this for scale. So the first one was, well, how many people might try to join our game at the same time, right? In this audience, we probably have 100, 150 folks, but I feel like trivia is something people really like, and so we're hoping that we might get 10,000 people try to join our trivia game. How do we handle that if everybody tries to join all at once? What happens if a user can't join the game initially? What does that experience look like for them? Are they gonna be frustrated? Are they gonna have to keep retrying? What does that look like? How should we associate a user to a particular game, right? How do we know that people are joining the reInvent 2025 game versus another game that we have? And then how do we identify users, especially in an environment where we don't want everybody to create a user account to play our game? So these were some of the scale considerations that we thought of when we tried to design this trivia application. So the first part of this process is talking about, okay, how do we get folks into our game? And so this is our kind of simplistic architecture that we thought about for what it looks like to get included into our game. So you have your client application, you're opening it on your phone. The first thing you need to do is establish that WebSocket connection so that you can get the questions and answer the questions. We probably want to persist that information as well into a data store so that we can keep track for doing things like scores and leaderboards. And so this was the general flow that we came up with to start. And this worked pretty well. But then we thought about, well, again, what if our game really takes off? What if we get 10,000 people that want to play it? How can we scale this to make sure that everybody is able to connect and join the game? That really sounds like the thundering herd problem, right? Where you have a lot of users try to join something all at once and you have to scale to support that load. And that's what we kind of came up against. So we thought about those 10,000 users and what that experience would look like if they tried to establish that WebSocket connection to our AppSync event API. And one really important thing to note, and this is true for all of our AWS services, is that services have quotas behind the scenes that kind of help us manage all of our users that use the services. And one very important one for AppSync events is what's called the rate of connection requests. And by default, this is 2,000 per second in each supported AWS region. And so we thought, okay, that's the default limit. It is adjustable, but we wanted to kind of work within kind of that base starting range for our trivia app. So we said, okay, if that is the quota that we're working within, 2,000 connection requests per second, how can we architect to make sure that we handle the case for those other 8,000 users? We don't want our AppSync event API to fall over. We don't want our users to get frustrated because they can't join the game. So how do we build this in a way that will scale very well? And so we thought about, well, we have other services that can do this really well, like API Gateway. API Gateway has built-in rate limiting through usage plans where you can effectively define how many requests to let in to a particular route in your API or even at the API level, and how many you can return with a 429 throttling error to kind of control the rate at which users can use your API. So we thought, okay, if API Gateway has that built in, maybe we can use that as a gating mechanism to kind of help us control the rate of requests for connections to our AppSync event API. So in this flow, the first 2,000 users hit that API and they get a 200 response back and they can hit and establish that WebSocket connection. The remaining 8,000 users that try to join are gonna get that 429 back from API Gateway. But what's really transparent to the user behind the scenes is the fact that your application client has built-in retry logic and exponential backoff. So that's a design choice that Brian and I made in the mobile application that you guys used to play the game, is it automatically will retry and do that exponential backoff. So eventually the remaining 8,000 of you will be able to join the game. And this worked really well for us. And again, is super transparent and is a best practice when you're designing for that scale. And so this really became our player entry control. So we had the application client hit an HTTP GET route with our API gateway. That also allowed us to validate the game ID. So it kind of doubled as player entry control, but then also making sure that you were joining a valid game ID and one that we hadn't created. We fetched and validated that that game ID existed in DynamoDB. And that allowed us to then also apply that rate limiting on the API request. So then once you receive that 200 response back, you were able to establish the WebSocket connection to AppSync events, and off you go playing your trivia game. So a couple other things came into our minds when we thought about designing this for scale. One of those was, well, validating the game ID is a super read-heavy operation, especially if you're all validating the same game ID. And so we used API gateway caching to essentially cache the validation response so that we're not constantly reaching back out to DynamoDB to say, hey, is this a valid game ID? Hey, is this a valid game ID? So that was a really good scaling mechanism, and one that is very beneficial to use for those read-heavy operations on your APIs. The second thing that we did, and you'll see it here, we use the first-class service integration between API Gateway and DynamoDB. If you're not familiar, API Gateway can directly connect to a lot of AWS services without the need for any compute in the middle. So we didn't use a Lambda to do that get item operation from DynamoDB. We just used some request mapping templates to essentially format our requests to do that operation directly to DynamoDB. That saved us compute, it saved us on cost, and it saved us on potential cold starts for when we're just starting up a new game. So that's a really good best practice for designing that REST API integration. And then the last thing that we did, again, to mitigate that thundering herd problem, was we used API Gateway rate limiting with our usage plan to make sure that you couldn't go above that 2,000 limit. So 2,000 might be pretty low, and again, we kind of worked within the default quotas, but this, again, is a really good best practice to kind of control that rate of entry into your applications and using your APIs. So essentially what that then looked like after we went through our player entry control is you were able to establish that WebSocket connection, and you were able to subscribe to all of the relevant namespaces and channels that are needed to play the game. One of the most interesting parts, and I'm going to talk a little bit about this, is so you subscribe, you establish that connection. How are we essentially tracking who's joining the game, right? Again, I mentioned this as one of our skill considerations. How are we identifying users, and how are we making sure that we're able to track them for their score and leaderboard updates throughout the entirety of the game? That to me sounds like some business logic, right? We want to be able to track and maintain who's joining the game as they're subscribing to the different namespaces. This is a really great use case for a little bit of code and what's called an event handler in AppSync events. And so effectively what this looks like is when a user subscribes to our game namespace for our particular game ID, we run a little bit of business logic to effectively capture their user ID, which we're including in their headers, and I'll talk about why that is in a second, and we're persisting that to DynamoDB, all as part of the subscribe operation. So there's no additional API call that's happening behind the scenes to persist that user ID. We're just doing that as part of the subscription. So it happens really seamlessly for you as a player. We automatically capture that user ID and persist it. So I'll come back to kind of why we're persisting or passing the user ID in the header. So we wanted you all to be able to play this game very seamlessly. You probably have come across things where you have to create accounts and do verification codes, and that all takes a lot of time. And so for really making this a simple game to play, we decided to just generate random user IDs on the client side and pass those as part of the header to identify each user individually. Now, ideally, you would probably want a little bit more sophisticated auth, especially if you want to track player statistics, but this is something that worked really well for us and allowed us to capture those user IDs and persist them. So this event handler, it looks a lot like something that you might run in a Lambda function. But interestingly, these event handlers are not Lambda functions. Event handlers in AppSync events are pieces of code that you can run to perform business logic. They run in what's called an AppSync.js environment. This is a lightweight JavaScript environment that has a subset of JavaScript capabilities that allows you to do things like event enrichment, validation on subscription, persisting data into different data sources, and it makes it really simple to do that, all while making sure you're not introducing additional compute and potential latency into your API operations. So again, this is not a Lambda function. It looks like a Lambda function, but it's not a Lambda function. It is an AppSync.js event handler, and they're really, really efficient for running this type of business logic. One thing to consider, though, from a scaling standpoint is, well, how do I make sure that I'm able to run all of my subscriptions and not hit any limits from a scale perspective? Event handlers use request tokens in AppSync. So let's talk a little bit about request tokens and kind of how that factors into scale. So for every request that you make to your AppSync event API, whether it be a connection, a publish, or a subscription, those are all requests that consume tokens. When you make a request, you get a log in CloudWatch logs, provided you have them enabled on your API, and it actually will tell you how many tokens that request consumed. And so this is a best practice as you're building and designing these APIs to test and see how many requests on average am I consuming for the different operations. The reason that this is important is because, again, there's a quota that we need to consider when we're designing. It's very similar to the rate of connection requests, but this one is the rate of request tokens. It's 2,000 as well per second per region. Generally speaking, when designing this for scale, most requests only consume about 1 token. This can vary, though, depending on how complex your business logic is. So if you're doing a lot of complex operations inside of your event handler, this can change, but that's why it's so important to do that kind of validation during testing to figure out how many request tokens you're actually consuming for the different types of request operations. All right, so to kind of summarize, what are all the things that we need to consider when joining the game? So the first thing that we need to consider is using direct integrations with AppSync events and data sources. So when we're persisting user join information, we were doing so via that event handler, right, that we just talked about. That event handler had a direct connection to a DynamoDB table. So again, we didn't have to introduce additional layers of compute into that flow. AppSync Events supports a variety of different data source integrations, from DynamoDB to RDS databases that have the data API to OpenSearch, Lambda, HTTP data sources. There's a handful of others, but these are really good because, again, you're not introducing additional latency into that flow. Additionally, we used DynamoDB on-demand capacity mode. DynamoDB, if you're not familiar, has 2 different capacity modes, on-demand and provisioned. On-demand is really, really great for scaling, especially when we don't know what our load is going to look like. And for this case, we didn't really know how many users were going to play our trivia game. And so that was a really great scaling mechanism for us to take advantage of. And then the last thing is, again, to use that built-in AppSync.js environment, along with those helpful utilities to interact with DynamoDB and do that lightweight business logic and processing. So that is joining the game. I'm going to hand it back off to Brian to talk about playing the game.
All right, thank you, Kim. Okay, so Kim talked about now you're all in the game. So you're in the game, we have you. What happens, or what happened when you were actually playing the game? So we're going to go through that. So first of all, I, the admin, I need to send you questions. So I need to get a question and broadcast it out to all of you. So we'll talk through that, how that works. Next is that all of you need to send that back to me, the admin. So I need to get all of your answers back to me, run some logic to figure out if that was the right answer, calculate your score, and then you need to see your individual score. So you all had individual scores that were cumulative. So again, that's application logic that I run on my side, but I need to get that back out to you. And you don't want to see that across all of your neighbors, right? I'm just want to get that out to each one of you as an individual. And then finally, you can see on my side, the admin screen did have the cumulative leaderboard. So we had the top five users there. So let's go through how that looks. So the first thing that we'll talk about is how me as the admin can send all of you the questions. And these are the different channel namespaces and the components that we're using here. So we're going to look at the first one. So in the first one, I click the button, I click Start Game, or I click the next question from my admin panel. That actually goes to a Lambda function. And the Lambda function just runs a little bit of logic, not much. It's going to grab the question from DynamoDB, create some little payload, and then publish out to this channel namespace. And the channel namespace is /question, and then the game ID, which was RIV 2025. And of course, we are using an API gateway in here. The front end application rather, does just send a regular HTTP request to API gateway. API gateway then invokes the Lambda function, and the Lambda function is executing that publish API to our channel namespace. And what the publish payload looks like is what I said earlier, which is the question, so it's the text, the question ID, and then you have all of those 4 answers. So on your screen, you saw the 4 answers to choose from. So we're just getting that, again, from DynamoDB, doing a little bit of formatting, and broadcasting that out. Now, the nice thing here, going back to scale, is that here we had 100, maybe 150 people. The nice thing is that if we had 1,000 people or even 10,000 people, I don't have to change anything. AppSync Events is going to handle that broadcasting for me. There's nothing extra that I need to do. It's got me there. It's going to handle all of that for me. So that's a really, really nice feature. If you're doing this yourself with homegrown WebSockets, you're going to have to deal with that. You're going to have to handle how can I scale this out as my application grows or as I need to support more and more users. So this is one of my favorite parts of AppSync Events is just that automatic broadcasting. Okay. How does authorization work? So Kim mentioned that here we wanted this to be really, really easy. So there is no login authentication. So we kind of fake it in some ways where we just create a random user ID. But still, we don't want to have this completely open to the world. So how does this work? We use 2 different types of authorization in our application. So the first one is a traditional IAM role. So this is what most people are familiar with. This is when you have the service-to-service communication. So in this case, we authorize our Lambda function publish access to our AppSync event channel namespace. So that is, this Lambda function is allowed to call publish on AppSync events. So that's the authorization method here. So if you somehow got a hold of my credentials and tried to publish to this, you wouldn't be allowed to, right? So we trim this down really small and have least privilege access so that only the Lambda function has access to publish to this channel namespace. On the other side, who is allowed to subscribe to this channel namespace? And so for that, we're using an API key. And an API key is something that we created within AppSync Events that's actually embedded into the front-end application, so you all have access to subscribe to that. So if I was trying to open up a WebSocket connection to our channel namespace without that API token, I wouldn't be allowed to. So it's somewhat coarse in the sense that anyone here can use it, but again, because we're using essentially anonymous users, all of you, this was the route that we took, and it does work out quite well. So how does authorization work with AppSync events? So there's something known as a default authorization method. So a couple points here. One is there is a default method to create the connection to the AppSync events. And for that, you can use either an IAM role or an API key, like I was mentioning. There's also a publish default authorizer and a subscribe default authorizer. And so with this, the default authorization method for both of those connections, or for both those actions rather, is an IAM role. And you might be thinking that doesn't really make sense because how do you use an IAM role if you're subscribing? So the nice thing here is that you can actually override this on a per namespace basis, which I'll show next. So here we've got our 4 channel namespaces. And the authorization scheme works where we have AWS Lambda publishing to the first 3 channel namespaces. So publishing questions, scores, and then the leaderboard. And again, for that, we're using the IAM rule. The Lambda function is allowed to publish to those channel namespaces. On the subscription side, we're using API keys, like I mentioned. So all of you are subscribing to these channel namespaces, or the admin interfaces is using the API key. You're all using API keys to subscribe, as is our admin interface. So API keys on that side for the subscriptions. You are also publishing, you the consumers or the players are publishing answers to our channel. And for that, we also use the API key. Now you'll note here that no one can subscribe to your answer. So if each one of you is publishing an answer, we want to prevent someone else from being able to subscribe to that and snooping on your answers and cheating. So if you think back to what I had earlier, where the default authorization method for the answers namespace was an IAM role, but we override it here with an API key for the publication, but nobody can subscribe to it. The only way to subscribe to it would be with an IAM role, and none of you have IAM roles, so there's no possibility of cheating here. And I'm talking about 2 different authorization methods, IAM roles and API keys, but these are not the only ways that you can do this. So you can use a Cognito user pool for this, custom Lambda authorizer, and one more, which is the Open API authorization method. So you have those options available to you if these don't suit your needs. Okay, so now I've explained how I'm sending all of those answers and broadcasting, the questions and broadcasting those all out to you. So what happens when you need when you answer a question and send it back to us? So there's our diagram. This is the next section, is you are all publishing to the answer namespace. So answer and then our game ID. So you're literally sending, the front-end application is sending that, a WebSocket publish to that namespace. So what happens? So behind the scenes, what's happening is that we have connected a Lambda function to that channel namespace. Now remember, Kim was talking about these the AppSync event handlers. So now we're going to be back into the world of Lambda, because this thing is going to need to run a little bit of application logic. And what it's going to do is receive the payload from each one of you. It's going to do a little bit of validation logic. So it knows the question that's being answered. It knows your answer, and we need to figure out, is this right or wrong? So if it's wrong, you don't get any points. If it's right, we're going to go and calculate your score. So that's what that highlight is there, which is the validation logic. Like, is this correct? We're in a little bit of application logic, like I said, and then after that, we're going to send back something to you, which gives you your cumulative score, whether you were right or wrong. And so that's what's highlighted here. So we run that application logic, score you, and then the Lambda function is now publishing back out to a new channel namespace, which is specific for your users. So that's why each one of you was getting a specific or a unique response back with your score, whether you were right or wrong, how many points you got, and things like that. So again, there are no event handlers here in the AppSync from the AppSync event world. This is a regular Lambda function that we're using here. And this one happens to be running an asynchronous Lambda function, because here, if you think about it, asynchronous response is I'm going to send something and wait for the response to come back to me. But in this case, we don't care about the response because we're in the WebSockets world, right? We're using AppSync events. So the publication goes out, your message goes out to us with your answer. It's not waiting for the response back from AppSync events. We get that message, do our work, and then our communication channel back to you is another publication over this channel namespace. So again, we're leveraging the asynchronous version of a Lambda function. Okay, I'm going to hand it back over to Kim to go over the next bits of playing the game.
Awesome, thanks, Brian. All right, so you've sent your answers, we've validated your answers, and now we got to score you. So let's talk about how scores go out. So we're focusing on kind of this area of our game now. So one really critical thing, because I know if you're like me, you don't want other people to see if you got an answer wrong. Like, I'm really protective of the answers I give, especially when they're not right. And so you don't want other people to be able to subscribe to your scores to see what your score is. And so we're able to actually do a level of enforcement on subscription. So when you subscribe to the scores namespace, we actually embed your unique user ID into the channel segment that you can see on the left-hand side. Once we do that, in the event handler, we can actually enforce that you are only able to subscribe to a channel segment that contains your user ID, right? So we look at the headers, we get your user ID, and we validate that those match. And that's that little bit of logic right here. If they don't match, we essentially return a result that says you're unauthorized. You can't establish this subscription. And this is really powerful. If you think about a use case where you only want users to subscribe to notifications that are designed and destined for them, this is how you enforce it. So this little bit of code in the event handler is a really powerful capability for kind of enforcing that level of authorization on subscription. And then to actually publish out the scores, this is also happening in that asynchronous Lambda function that Brian talked about, where we validate the answer. We then just publish out the score update to all the individual users. One thing that I want to highlight is that we are using async, again, for this purpose because we're doing a lot of logic in here and it's going to take a little bit of time. And for that, it really makes sense to use a Lambda function. We're writing to Dynamo, we're fetching from Dynamo, we're publishing over another namespace. These are all additional operations that we need to do in a Lambda function where we can't do all of that inside of an event handler. And that's really one of the differentiators between the two. And that's that little bit of code down here. So then, everybody needs to be able to see the leaderboard on the admin view so you can kind of see where you are in the state of the game. And so for this, we take a little bit of a similar approach, but we introduce an additional service, or a part of our service, which is Amazon DynamoDB streams. And so effectively what happens here is when we write the scores to the DynamoDB table, we are actually enabling a DynamoDB stream to do change data capture to get updates to that DynamoDB table. The Lambda function that we have here is consuming from that DynamoDB stream in batch. There's a lot of configurations that you can do on that event source mapping between the DynamoDB stream and the Lambda function. And so we're able to process a bunch of those batch records all at once to reduce the number of times our Lambda needs to be invoked. Inside of that Lambda function, we're essentially doing a query to get the top 10 scores and publish those out once to our leaderboard namespace. We're doing this effectively to reduce the number of leaderboard publish operations that we have. We thought initially about publishing every single leaderboard change. That was quite a lot, especially as we have many, many, many users playing the game. And so we decided to reduce that down to just getting the top 10, which is why you see the code that you do here. But we're still publishing out to our leaderboard namespace from within a Lambda function. And so this is very similar to what you've seen before, where we're publishing out scores and we're publishing out our questions for the rest of our game. So we've talked about a lot of different things for joining the game and playing the game. So let's kind of summarize all of the different things that we thought about when designing this for scale for the back-end part of our application. So the first thing, and you've probably hopefully picked up on this as we've been going through the presentation, is we really focused on segmenting our channel namespaces by game function. This became really important because each part of our game serves a different purpose, right? Questions need to go out to you, need to be sent from the back end. Answers need to come from you, sent to us, scores, leaderboard, and so on. And all of these things have different capabilities from an event handler perspective, from an authorization perspective. And so it was really important for us to design that level of segmentation at the channel namespace level. That then enabled us to do use case driven authorization, right? So having IAM roles where it made sense, having API keys where it made sense, and that is only possible by having that level of segmentation at the channel namespace level. Additionally, we leveraged a lot of the great AWS AppSync capabilities that come out of the box, like message broadcasting, fan out, connection management, all that good stuff. We didn't really have to do a whole lot there. We kind of got that out of the box with AppSync events, but that's why we chose it. It scales very well when it comes to things like that, and that was one of the reasons why we went with that service. One of the other things, I don't know if you caught it, hopefully some of you did, but in our async Lambda function that's handling the answer logic and the score updates, we actually used power tools. How many of you have heard of power tools before? Okay, great, I love it. I'll have to tell the power tools team, they'll be super happy. If you haven't heard of power tools, definitely look it up after this session. It is one of the easiest things that you can do to integrate observability into your Lambda functions. In this case, we are using it for logging and sending metrics, but we're also using it because the Power Tools library has really nice Lambda decorators for different types of event sources, and they have one specifically designed for AppSync events that allows us to handle the integration between AppSync events and the Lambda function a lot more seamlessly, get nice typing if you're using TypeScript, and then compile down to JavaScript. So definitely check that out. That was something that really helped us, and again, when you're designing for scale, building that in is a necessity from a logging and metric standpoint, and Power Tools just makes it all that more easy to do. And then finally, async Lambda invocations for those longer running processes. This is one of those best practices that might seem a little repetitive to some, but I talk to a lot of customers who are still using synchronous operations for everything. And I think async is really one of those things that when you're designing for scale, you really need to think about, does the caller of my API need that response right away, or can they wait? And especially for this application, being it's driven by WebSockets, we're gonna have the updates sent anyway over a different channel, and so using async was really, really powerful in that sense. So we talked a lot about the back end, probably way too much, and we didn't talk enough about the front end, so we wanted to highlight a little bit about how we are hosting the application that y'all interacted with, and talk about how that is designed for scale. So I don't know about you, hopefully some of y'all have tried to host like a single page application on AWS before. One of the things that always pops into my mind when I'm trying to host like a React application is, oh, just stick it in S3. And I might front it with a CloudFront distribution. This is a really simple way to get a single page app spun up on AWS. S3 actually has like a really nice hosting way to do this out of the box, but you probably want to put CloudFront in front of it to get that CDN capability. But then if you think about it, okay, how do I extend this and scale it out for like enterprise level? You're probably going to want to stick a web application firewall in front of it just to make sure that your application can't be DDoSed. You do some level of control from who can access it, all that good stuff from a security standpoint. You probably will then also need to look at getting a certificate, especially if you want to put a custom domain on that CloudFront distribution. So you're going to need to incorporate Certificate Manager to make sure that that URL can be accessed over TLS or SSL and HTTPS. And then you're probably going to need to use Route 53 or some domain name management system to register that domain and connect it up to your app. All of this is involved in hosting an application, and what started off really simple with S3 and CloudFront now becomes a lot of operational overhead that you then have to manage and worry about and operate and monitor and all that stuff. And so there had to be an easier way, and there is, and that's AWS Amplify Hosting. So AWS Amplify has a lot of components to it if you used it before. The one that we're specifically using in this trivia application is the hosting component. And so Amplify Hosting does all of the things that you saw underneath, all for you. You can bring your own custom domains, you can connect up a web application firewall, you can host both single page applications and server-side rendered applications with a variety of different frameworks. And so this was a really easy way to host our application, and that is what we're using and what you interacted with when you were playing the game. I wanted to spend a little bit of time talking about monitoring and observability because, again, when you're operating at scale, there's a lot of things you need to look at and make sure are scaling properly and not falling over. And so we wanted to highlight a couple different metrics and things that we considered when we were designing this application. So there's a lot up here, but a couple that I wanted to highlight are AWS AppSync events metrics. So these come out of the box. One that's really important is that connection request rate. So remember I mentioned this is one of those things that has a quota of 2,000 requests per second. So you want to monitor how many users are trying to connect at the same time. An important note I want to highlight is that there's no limit on the number of actual connections you can have. It's just the rate at which they can connect and initiate those connection requests. You can also track, and it's really helpful to track the number of active connections that you have, so you can see how many people are connected at any given time. Also, how many people or how many clients are subscribed at any given time. There's a lot more when it comes to AppSync events, but these are a couple that we wanted to highlight as really critical. For AWS Lambda functions, since we have a few of those in our application, we definitely want to take a look at the number of invocations as well as our concurrent executions to make sure that we are within our limits. Those are also generally raisable from an account standpoint. And then we're using DynamoDB, like I mentioned, in on-demand mode. And so we really wanted to also make sure that our read and write usage was kind of on par with what we expected. And so these are some of the ones that we decided to take a look at and monitor within CloudWatch. As we're wrapping up here with a couple minutes left, I know it's Tuesday. I feel like it's already been 4 days of reInvent. There's still 2 more days left, and so I wanted to plug a couple more sessions. One that we have tomorrow morning with yours truly is a builder session focused on real-time applications. You'll actually be able to get hands-on with AppSync events in this one, so definitely take a look. Come to the wait line if you don't have anything scheduled. There's some other good ones like Serverless Espresso, where we are actually using AppSync events to give you updates on your coffee order. Definitely check out this workshop or go see it in the Expo Hall or the Training and Certification Lounge. And then who doesn't love best practices for serverless developers? Also wanted to leave you with a couple resources. I'll give you a second if you want to grab a picture of these, but this talk will be up on YouTube probably in the next couple days. AWS AppSync Events User Guide, the Power Tools documentation. Again, can't stress that one enough. Power Tools is super easy to get integrated and really, really beneficial. And then Serverless Land, which has a ton of useful content, a lot of sample code that you can take and leverage to implement some of these patterns. Definitely check those out. Thank you so much for sticking with us at the end of Tuesday. For those of you who are sticking around, I might have a prize-ish for playing the game, so come see us after. But Brian and I will stick around if you have any questions, and please complete the session survey. Thank you guys so much.